Pro.
Keeping on. Speaker.
Doing really well.
Every time. Oh, yeah, I'll take it for now.
We'll just give us like a couple of minutes for others to join in.
While we're waiting, can I ask a question?
Yeah.
I think project proposals are due in like a week. Week and a half. Is there like a template or more info? I like can't find, or I don't know if I'm just missing where to find like kind of project proposal template info.
So there is a project rubric. I don't know if you still have access to that. Do you?
Yeah, they gave us a Google sheet, but it doesn't really have like a proposal. Like how formal are the proposals supposed to be, I guess?
Or like you're asking like the format?
Semester we didn't necessarily, but we do have a rubric. Basically, last semester we ended up just heavily focusing on did people cover all the things in the rubric that were asked, and they made a PDF submission based on that.
I'll check on this and get back to you. Like we don't officially have, I think, a format that you need to submit for the proposal at least.
Okay.
Let me check. Like I can provide you like a couple of examples from last semester, like how students did it.
Yeah, that would be helpful because my team picked a paper, but we're just like,
Okay.
now what? Okay, thanks.
Yeah, as long as you stick to the rubric, I think you'll be fine.
Fine, okay.
There's actually a Piazza post on that. Check like Piazza post number 12.
Number 12, okay.
Yeah. Okay, I think we can get started. Some people are on Zoom. I hope you guys can hear me clearly. So good morning, everyone. I appreciate people who have come in like on Friday morning in person. I know it will get harder and harder over the semester to be in person, but I would just still recommend the ones who have enrolled in the in-person section just try and be here in person because that seat comes at the expense of another student who wanted to be in person but could not, unfortunately, because we have like limited spaces in the in-person section. So welcome to Lab 3. Today we'll be talking about debugging deep learning networks. This is one of my favorite topics of one of my favorite labs in the semester. So I hope you guys will enjoy it as much as I do. Before we get started, some of the announcements here. So quiz 3 goes live today, and it will be due at our regular time, which is like Sunday, 11:59 midnight. Homework 1, part 2, as well as part 1. So deadline is approaching. That's due September 20th. Project group list is out, so I hope you have checked it out on Piazza. And I believe study groups will be out soon if they are not already. This is just an FYI, so there is a seminar after this recitation in NSH room 4305. It's being taken by Dr. Andreas from Austria. It's have to do with deep learning on image data. So if you're interested, I would definitely recommend try and be there in that seminar. It will be exciting. Also, just to mention here, so I was going through your Kaggle leaderboard, and I find like people are not being creative with their usernames. Like this is what the Kaggle leaderboard looks so far for you guys, and there are two people here who are not being creative enough. I hope those are not the two same students, because if they are, then we'll have to talk like separately one-on-one. But again, just to give you a glimpse of like you can be creative with your usernames. As an example, this is from the previous semester. So people had fun keeping like funny names on Kaggle. It's not necessary, but it's just a nice nice way to have fun because you'll find out it's easy to burn out in this course over the semester, and these are some of the light-hearted moments that you'll enjoy over the course of the semester. So try and be creative with your Kaggle usernames. Okay, so coming back to the main topic of today, that's debugging. So if you are from a CS background, you are already aware of this. So debugging is a painful task in CS. But it's even more painful when we talk about debugging in deep neural networks because we have the issue of these neural networks failing silently. What do I mean when I say failing silently is, there will be no error, there will be no traceback error for you to look into. It's just that the model is not performing well, the accuracy is down, so you need to debug like what's going on in these networks. And that's sort of the difficult task when it comes to debugging in these networks. So we'll touch upon these topics today, and hopefully it will help you over the course of this semester. So that's the goal. When we end this recitation, we'll have learned the skill of debugging some of these neural networks on your own. And that's what's on the agenda today. We'll take a look at one of the sample IDs, which is like VS Code. I'll walk you through like how you can debug some of your homework part ones. And then we'll talk about Python debugger, which is PDB. It's going to be useful in your homework part twos. So these are two very essential tools that you will be using very frequently in this course. And then we'll talk about some of the other stuff, like what you can do, like when you're building a model, when you're training, testing, all sort of that stuff. So starting off with how to debug your part ones, I'll give a brief demo of a VS Code. So if you guys have your laptops along with you, you can follow along as I go along. Pull up. So this is VS Code. It's not necessary that you use VS Code for your homework part once. You can use any other IDE, which is like PyCharm or any other IDE. The debugging stuff will vary a little bit because if you're talking about PyCharm, it has its own debuggers. Today we'll just go over how you can do it in VS Code. So if you have your VS Code open, this is homework 1, part 1. I thought, I'll just go over one brief debugging scenario in homework 1, part 1, so it's more relatable to you guys. So let's say if you have like any part 1 open in VS Code, on the left you'll see you have all the files. Let's say you want to debug like your linear layer. You'll simply go over and create like a breakpoint somewhere here. Like let's say you create a breakpoint here. I hope all of you are aware of the concept of breakpoints. Uh, so once you create a breakpoint, you see on the left menu, you have like a debugger option where you can run and build the solution using your VS Code debugger. It's important that you switch on to the autograder file because the debugger will launch from there. And once you are on the autograder file, you click on this debugger. When you're doing it for the first time, it will give you some error or some prompt like you have to create your JSON file, like a launch.json file. Just create that. By default, it will work right off the box. Once you have created that launch.json file, this is the window that you'll have. And you simply run the instance using the Python debugger. So once the debugger runs, your breakpoint will take a hit. And at that point, you can do lots of stuff around your code, like having a watch expression on, like if you want to check some of the shapes, you can do that. Let me see, did it run? Okay. So the breakpoint is right now hit on this line number 28, which is like doing a calculation of your Z input. So let's say I want to, there is on the terminal, there is a debug console for you to look at some of the things, like let's say what is the shape of A. So you can just do a.shape here, and it prints out the shape. So this method of debugging is so much better than having like print statements, somewhere around your code, and then you have to like rerun your program again and again and insert more print statements. It's better that you apply the debugger thing and use this debug console to see what's going on. So let's say, if there was some error, let's say I change this. I change this and I rerun it again. So hopefully, like this, when you have taken out the transport, it should give you an error. So there are like controls over here where you can step over the code, you can step into a function, you can step out of a function. The regular breakpoint controls, you have it all here. So now when I go to the next statement, now it's giving me an error. So sort of this error, you can do it beforehand on the debug console to see what's going on. So you can individually copy one of these expressions here. Go to your debug console. And it gives you the exact error what was there. And you can, like if you have a very long equation, if you have a very long expression, you can divide that expression into mini expressions and use them here directly on the debug console to see which of those mini expressions are failing. So again, a very interactive way of debugging on VS Code. Yes?
Like, is there a way to run this debugger within a virtual environment?
Within a virtual environment?
Yeah.
Yeah, you can do that. I'm running on virtual environment. But again, very, very standard process of applying breakpoints and seeing all the values. Any questions on this? Are you guys able to run? Yeah.
I have faced, not specifically in this course, but I have faced a problem when I'm debugging, like I'm facing some error, but when I'm running the code, there's no error. Is it any like a specification on like a debugging mode of the Python?
With VS Code, not really, because you just have to make sure that homework you are on the autograder file because it has like debugging flags on. And if you run this file with a debugger, it will identify those debugging flags and it will act in a debugger mode. So if you are not running in a debugger mode, then of course all of those issues will not be pointed out. So it's essential that you are on the autograder file and you run the file in in debugger mode. Any more questions on this? If you're using PyCharm, the process would be sort of very similar. PyCharm has its own debugger, so you can try that out. But what BS Code, this is the process. Okay, if no more questions, I can move on to the second part. So second part here is how would you go about debugging your part 2s, which requires the use of PDB, which is the Python debugger. Have any of you used GDB before? So you are aware of how GDB works. PDB is very similar to GDB. You have almost the similar commands, and you can run this on your Colab notebook, wherever you are running it, be it on GCP or just the standard Colab. So give you an example here. So this is, let's say this is my file here. This file is from the Recitation 0n part, so you can go and download this Colab file from there as well on the website. So let's say if I run this, and I execute here cell. So this cell is giving me an error. Let's say I want to debug like what's going on here. Let me execute some of these cells here. So by default, whenever you are running a file which has like Python installed in it, the debugger comes with it by default. And you can execute like based on whether you want it to execute on its own automatically, or you can also do it manually. So if you want to do like initiate the debugger manually, let's say if this function is having an error, you have the %debug command here. So when you run this, it will launch the PDB terminal mode. So now you are inside the debugger mode. Let's say you want to see what was the value of A. So you do A, you can also do B. So you can see when we are doing A divided by B, so that's where the error is coming. And so this is one way of using PDB on your part 2s whenever you are running a notebook. Whenever you run into an exception, just do initiate the debugger manually like %debug, and it will launch this mode. You can also look at some of the help commands here, like just do H, and all of these commands will pop up. Again, the ones who have used GDB before, this is very much similar to GDB debugger. Now let's say you don't want to do the manual initiation of the debugger. There is also one automatic way of doing that. You have to keep a command like %pdb on. When you keep this and you run it, whenever the exception is raised, you have to like close this first. So whenever an exception is raised, PD will launch on its own automatically. And again, the same process, you can print out shapes here, you can print out variables, model parameters, anything you want. Again, this is very similar to like having watch variables or watch expressions. But again, if you don't like this way, there is another way of setting breakpoints using PDB as well, which is like you would have to import the PDB module and then use this command like pdb.setTrace to keep a breakpoint on that line. So whenever the execution will come to this line, it will stop and it will launch the PDB terminal module. Again, same module, same commands, everything works in the same way. So this tool is going to really help you in debugging like how your model is going layer by layer, because having print statements in your network class will be like a very messy way to debug your model. So in order to do it like efficiently and effectively, you should use PDB. Any questions on this? Again, if you are from the CS background, this is like very repetitive stuff. Okay. Okay, so let's talk about the homework part 2's ideal workflow. Now from here on, you guys will be doing the majority of the lab. I'll be asking you like a bunch of questions. So if you have not woken up yet, it's time to wake up. So homework part 2's ideal workflow, you have to download the notebook. It's pretty standard workflow. Download the notebook, complete all the to-dos there are in the notebook, and divide the experiments among your study group for like efficient training of the model and trying out like different sets of hyperparameters. And then homework part 2 is there are different components, like you have to load the data, you have to pre-process the data. That's standard. After that, you'll go on and build your model, followed by training and then testing. And the last step is Kaggle submission. So how would you go about debugging each of these individual components in your notebook? We'll talk about that. So in any machine learning task or in any like AI related task or deep learning task, as an engineer, as a researcher, your important task is to figure out like what kind of data you are dealing with. If you understand the data that you are dealing with, it will be more easier for you to build a model around it. So for example, let's take homework 1, part 2. So what kind of data are we dealing with here?
Noise. Audio.
Yeah. So we have like audio speech recordings, and what are we trying to output?
A label, a scalar.
Phoneme, yeah. So a phoneme like maps to a scalar maps to a phoneme. So for every speech recording, you're trying to predict what is the phoneme mapped or corresponding map to that speech recording. So this is like one sample, speech recording, how it looks like. So whenever you start any homework, like going forward with homework 2, 3, and 4, it's important that the first step that you take is initialize or just see what kind of data you are dealing with, what kind of input your model is expecting, what kind of output are we expecting for your model to do. So once you understand all of that, it is easier for you to write code as well. So for example, in this homework 1 part 2, let's say we have some MFCC audio files. Let's take a very small example. We have like 2 MFCC files. Each MFCC file is of shape 10 by 28. 10 meaning like you have 10 time steps or 10 frames, and you have 28 features. What is the next step that you did, in this workflow?
Added some padding.
Directly? Yeah, so you have to normalize each MFCC file. Does it change the shape of your MFCC? Yeah, so it doesn't change the shape of your MFCC. What after that?
Context.
You have to concatenate all the MFCC files. Does this change the shape of your input?
Yeah.
What would be the shape now? Yeah, so 20 by 28, because you had like 10 by 28, 10 by 28, you concatenated both, you have 20 by 28. What's the next step? Yes, pad the context. Let's say we are padding this with a context of 10. Will this change the shape?
Yes.
Yeah, what's the shape now?
40 by 28.
Yeah, that's correct. Next step?
Flatten it.
No, you have to like break the data into frames. Remember in get item? Now will this change the shape? What would the shape now? So the total number of frames in this way would be like 20, because you are striding with a time step of 1. So if we have like a context of 10, you'll have one final matrix of 40 by 28, and the number of frames that you will be analyzing would be 20. What about after?
Sorry for the interruption. A question from the Zoom. Because I think there is another way to do this kind of process. That is, we first padding each MCC file from after the normalization, and then we concat them together, and then we add the yes. But I think in this way, I have tried this method, but it didn't work as well as this one. But I think it is more makes sense because among different MCC files, they make the the information may be very different. So I think maybe concat first like padding them after first padding them, then concat them may more make sense. Can you explain that?
Yeah, so there are like two methods where you can like go about this. In any like, in general, in any machine learning task, there are like multiple ways of how you go about processing your data. This is just one sample example of how you can go about processing this kind of data. There are multiple ways, like a couple of them are already mentioned in the write-up. It's one that you mentioned, like, you load the MFCCs, you first pad them, and then concatenate them. That's also one way you can go about this, like, training your model. But the way the solutions are set up, it might not work well for you, that particular case, because let's say your one MFCC is very short in time steps, and the second MFCC is like very long. So you are unnecessarily adding like padding zeros to one of the MFCCs. So if you go about that way, there will be like many intermittent zeros in the middle of your data set, which is like not giving the model any information. So you can go about that as well, but for this homework, the way the solutions are set up and how the grading is done on Kaggle, we recommend that you go about this way. But both options are possible. For the second option, you would have to like handle it like very intricately, because now you would have to keep offsets or where your the padded zeros are ending and where are the padded zeros starting in your each MFCC. So that that implementation of that would be tricky.
Thank you. Thank you very much.
Okay, what's the next step here? You can apply time masking or frequency masking. Would this change the shape of your MFCCs?
No.
Yeah, it won't change the shape of your MFCCs. And the next step, you have to flatten and convert it into a tensor. Now, will this change the shape of your MFCCs?
Yes.
Yeah. So now this is just doing a flattening. We'll just simply do 21 into 28, so that's your 588 elements. And in case
Hi. Hello.
yeah,
Sorry, can I ask that you do like a very brief explanation of time and frequency masking, if that's okay?
I'm sorry, can you repeat that?
So I was asking like if you could do like a brief explanation of time and frequency masking, like what exactly does it mean in this data set?
Oh, so time, I think we have a slide on that, so I'll talk about that in one of the later slides.
Oh, all right, thanks.
So the next step on this would be like if you're using your data loaders, you will batch your data. Let's say if you keep a batch size of 5. So if you have 20 frames to analyze, you will have 4 batches. Each batch will have 5 samples. Pretty standard stuff. Same process would go for the transcript as well. So, but here, let's say each file of transcript has 12 time steps, whereas your MFCC had like 10 time steps. So where are the 2 extra coming from?
They are the start of sequence and end of sequence indicators.
Yeah, that's correct. So you have the EOS and the SOS token in your transcripts, which you have to remove. And then your transcript will be of size, exactly matching your MFCCs. And then we follow mostly the same process, and you follow along like concatenating the files, you convert them into tensors, and then group them into batches if you're using data loaders.
Question.
Yeah.
Yes, so I was asking, what is a better approach? Like applying the time. So the time, time mask and frequency mask are more like augmentations, right?
Yes, so they are like, data augmentation or data transformation techniques. In order for your model to generalize well on the unseen data, those are the two techniques that you can apply on this data set.
Yeah, so the question would be like, is it better to apply them in the dataset class or to apply them in the data loader? Like what would be more feasible in terms of one, uh, the training speed? Yeah.
Right. Again, like, there are multiple ways of doing that. The end goal is that you need to send these normalized, or sorry, when you apply time masking and frequency masking, you have to send the data to your model. And it matters in some ways where you apply the masking. You can do it in the data loader's collate function. You can also do it when you are initializing your model. And I think you can do it like in the constructor of your dataset class as well. So again, every method has its pros and cons. It just depends on what kind of data set you're dealing with, what kind of model you have, what are you trying to achieve through that sample technique. But there are multiple ways of doing that. Does that answer your question?
I mean, yeah, in a way, what was confusing me is that, okay, like, what are the pros and cons of applying it, let's say, here, as opposed to applying it, let's say, when you've already defined like, is it like a big trade-off, or it's like really the same if you apply them in the dataset class, and if you apply them in the data loader, it would be the same thing? I think that's what I'm trying to ask here.
Yeah, so like, data loader, the way it works is it does the batching of the data, when that data is required. But when you are creating your data set, you're loading all of your data set into memory at once. So if you're applying, frequency masking there, and time masking there, it's going to be a little slower. Whereas in data loader, when you do it like on the fly, data loader will apply it just when that data is required. So it can be faster that way. Whereas if you apply, the time masking and the frequency masking when you are initializing your model, then again, that will have its own pros and cons. Again, the end goal is whatever data is going into your model, you need to apply the frequency masking and like the time masking wherever you see fit. Some ways have like, better performance, some have slow performance. Again, depends on the use case. All right. So this is like one of the sample speech recordings. Also on the left we have like a raw MFCC. This is what it looks like. And when we like take out a bunch of frames from that MFCC, it sort of look like what's on the right. And then when you're creating or like you're creating your batches through your data loaders, you batch multiple of these frames together. So in the first case we have a batch size of 4, whereas on the right we have a batch size of 15. So you have like 15 frames over there, you have 4 frames on the left. So how you go about creating your training dataset class and your test dataset class. So in your MFCC, this is the process that you generally follow. You can also see these are the comments that were there in the notebook. Like, you have to sort the files, load them, normalize them, and then apply all the, operations given. How does the test dataset class differ from this is for the MFCCs, you have to follow the same process, except you don't apply the time masking and the frequency masking, and you don't have transcripts on your test dataset class. So the test dataset class looks very similar to your training dataset class in terms of MFCCs. All clear? This was already given in the notebook. Yeah.
Is the time frequency masking applied in the dataset class?
For the test dataset class?
For the training dataset class. So is it implemented in the get item function?
You can, again, like you can implement it in get item. You can also have your collate function. In collate function is the one that your data loader calls. So when data loader is creating batches of your data, you can also, mask the data then. Or you can also do it in the init function when you're loading your data set.
So, because I implemented first in the dataset class and it was really slow.
Yeah.
And then I try to pull it out after it is moved into the GPU and it becomes faster.
Yeah.
So, is the masking done in the GPU when it's in the data loader, or is there like parallel processing or?
Yeah, so when data loader is happening, like it's creating batches, that all of that is happening in parallel. So when data loader calls the collate function, you have like multiple parallel computations going on, like creating batches of data, and it's in a way better that you do it in there rather than having in the dataset class, because when you're loading your data in your dataset class, all of that is going to your CPU. It's not on GPU yet. So that tends to be slower.
Okay, okay.
So it's better that you do it like when your data loader is creating the batches.
Thank you.
Yeah.
Wait, sorry, just to clarify, what is the data loader function that we should be masking?
The collate function?
Yeah. What is it?
The collate function.
Okay.
Yeah. So if you haven't seen the recitation on data loaders, we talk about the collate function. It's not necessary that you use collate function in this homework, but going forward in the homework 2, 3, and 4, you will have to use the collate function. So if you haven't watched the recitation on data loaders, I would highly suggest that you go ahead and watch it. Because right now what you're doing is you're just calling the data loader object, and by default, whatever it does down the background, you're just keeping it as it is. You're not using your own customized data loaders. And collate function is a way to do that.
Thank you.
Okay. So these are like 3 options. We have a possible option of 0 context, a context of 5, and a context of 20. Does anyone care to guess like what is option A? Out of 3 possible options: context 0, context 5, and context 20. How many say context 0? 5? 20? Not confident? Okay, well, why 20?
Because it's like flatted more, how do you say? I mean, average more, I don't know.
Okay, the ones who say 5, why 5? Oh, well, the ones who say 0, why 0?
Because of the time steps.
Yeah. So if you look at the time steps, the first one is not using any context. It's just one frame itself. And if you look at the time steps for option B, you have like 10 time steps, which is meaning like you have a context of 5. And you in the same way, the third option, you have like a context of 20. So when you keep on adding context, this is how your MFCCs generally look like. Okay, so more MFCCs. Now we have the possible options. One of the option is a raw MFCC. Another option is normalized MFCC. And then one of them is using time masking, and the other one is using frequency masking. So which one is the raw MFCC? Huh? Who says first one? Any other answer?
Option B,
Why option B?
because option A looks masked.
Yeah, so option A here is the raw MFCC, because if you see like some of the features on the lower portion of this MFCC, they have information, whereas the other portions or the other features at all time steps, they don't have any information. So once you normalize it, you get option B. So option B is your normalized MFCC because it has taken all the features from your raw MFCC and put it on a normalized level. Now, out of option C and D, which one is using time masking and which one is using frequency masking?
C is time masking.
C is time masking and D is frequency masking. So you got that.
Talk about the point of frequency masking. Is it just trying to say that like you're getting your network to sort of ignore, hopefully, like useless frequencies, but it almost seems like if you've masked a frequency that's, I don't know, important to the sound, that it's not learning.
Yeah, again, so that again, because you are running like different, iterations of your model, in every iteration, a different frequency will be masked.
Okay.
So if you leave out an important frequency in one of the iterations, it will get picked up in some other iteration.
Okay.
This is just to, so your model can generalize well on the unseen data.
Okay.
So it is kind of like dropout in that case.
Sort of, yeah. So dropout works on the model network level. This is sort of a regularization,
At the input.
sort of a regularization on your data set. Okay. So moving on, if you see any data loader errors like this, I don't know if you have run into this issue. So data loader employs different threads, which are also called workers. And if you see this error, try reducing the number of workers because maybe your GPU or machine cannot handle those many like high number of workers. So this is like standard solution for this. Okay, so let's talk about building a model now. So there are like a couple of options here by how you initialize your model. So this is pretty standard. Like which option is better than this one? The second one, because in that you are not like hard coding some of the numbers here, and it will help you like if you maintain a config file, you know, it doesn't matter a lot in homework 1 part 2, but it's still like a good practice because as you go along homeworks in the semester, your models will get bigger, your architecture will get deeper and wider. And to change some of these configurations, it's best to have like a configuration file. So there are two ways of maintaining your config files. Either you can create like a config dictionary, standard Python dictionary, or you can also choose the fancy YAML file option. So if you want to have, YAML is like, I prefer YAML more because you can add and stuff like as many configurations as you can, and it's more maintainable than your config dictionary. Okay, so this is one of the outputs for one of the models. How many total parameters are here in this model? Anyone on Zoom? I hope you guys are not sleeping.
3 million.
Which may be starting from January 2014.
I'm sorry, come again.
3.8 million.
Yeah, so 3.85 million is the total parameters for this model. So out of this architecture, what do you think like is the most computationally intensive layer in this model?
The first one.
The first one. And why is that? Because of the total number of parameters there. So when you print out shapes of your model or model architecture, this is one way of seeing like like which layer could be a bottleneck in your model architecture, or what could be a bottleneck when your training is going slower. So you can try and reducing some of these parameters or try moving around the layers. So it's good practice to be able to recognize and read this information that PyTorch gives. Okay. Quiz question. With no points awarded for this. What is the issue in this code?
There is a
Outputting the input size and all.
Layer 1 and layer 2.
layer.
Yeah. So layer 1 output size is 512, but layer 2 is expecting like a size of 1024. So this will error out on the shapes. So just take care of these shapes when you're creating your architecture. What about this? What is the issue in this code?
Layer 2 batch norm and it doesn't match layer 2's output size.
Yes, exactly right. So layer 2 output size is 1024 perceptrons, but your batch norm is expecting 512. So again, this will error out. So just try and keep these things in mind whenever you are architecting your model. Okay, let's talk about training and monitoring. So I hope all of you guys have created like your WANDB accounts and are logging all the metrics in that. This is one of the sample outputs on WANDB. What do you think? Like, should you go ahead training this model or should you stop it?
Stop it.
Why?
One is flat.
Which line is flat?
Accuracy.
Still not bad, 16.6. But yeah, you have to stop this training because if you see the loss graph, that graph, if you ever see, immediately stop your model because that is representing that your loss has gone to nam, which is like not a number, which is like your model has overshooted like the local minima or whatever the convex function you are trying to, approximate. So you stop this model and you restart again with different hyperparameters. Probably lower the learning rate here because the learning rate, if you see here, is 0.1, which is on the higher side. So one option here would be to stop this, restart it with a lower learning rate. What about this? Would you stop this one? Or would you continue training this model?
The learning is unstable, so maybe the batch size or learning rate needs to be, like the learning rate needs to be reduced and maybe the batch size needs to be increased in this case.
Learning rate, started off, I think that's pretty decent, 0.001. It's not that high, it's not that low.
Because it's fluctuating a lot, that training loss.
So you're saying you'll stop it?
Yes.
Anyone wants to continue training this model?
I'll probably use a scheduler just so that maybe the learning rate kind of reduces so I can see the behavior of the loss and the accuracy because the learning rate is not really fluctuating in any way. So the learning is unstable.
Yeah, so sort of that is the issue here. You can obviously continue training, you'll go nowhere because the main issue here is that your model is not converging here. So a good idea here would be to stop this model and then try implementing like a learning rate scheduler because the learning rate is constant here, it's not changing. So maybe try like a different scheduler here in this case. What about this? Yeah.
So I could just, how can you tell that our model isn't converging?
So if you see the validation accuracy here, it's very far off from your training accuracy and it's fluctuating. So that means it's bouncing off your local minima here and there. So it's not, the main idea is that you want to reach your local minima and it needs to take like incremental steps towards that local minima. But right now, because the learning rate is not changing, it's just bouncing off in that convex bowl. What about this one? Would you stop this one? Or is this fine? How many say this is okay? How many say not okay? Not one? Well, if you submit this, you'll get 0 points. Why?
I mean, accuracy is not good enough.
Accuracy is not good enough. So the performance of this model is not great, even after 50 epochs here. So you have to stop the training and consider increasing your model's complexity, maybe increasing the number of parameters, layers, and then do this thing again. Tricky, right? To read the graphs. Or this one. Would you stop it?
Right now. You can get it right now.
Zoom very well. It's gone beyond our high cutoff.
Yeah, sort of, yeah. But again, do you see any issue with this model?
Yeah, that's the learning rate's almost straight up 0.
Which one? What?
On the far right side.
The learning rate?
Yeah.
That's one of the issues, yeah. The learning rate has gone like way, way lower.
Validation.
Last 30 epochs, the loss is not decreased.
Yes. So that is again one of the issues, but I'm looking for like a very fundamental term here, which is like the boogeyman in
It's
machine learning.
overfitting.
Yes, it's overfitting. As my ML professor says, overfitting is the boogeyman in machine learning that you need to take care of. It gives you sleepless nights. So the model has started to overfit here because your training accuracy and validation accuracy has started to maintain like a gap now. And you don't want your model to do that. So again, you would stop this model. Well, not for homework one, part two. If for homework one, part two, if you get this graph, submit it because it is higher than 86%.
I
Yeah.
have a question there. So, like the training loss is higher than the validation loss in the second graph, but that's the case with dropout, right? Whenever we add dropout or some regularization, that is always going to be the case, right?
Yeah.
In most of the times.
That's actually a very good observation here. So the validation loss is actually lower than the training loss here. Again, that depends on what your model architecture is. It is possible that your validation data set is way, way lesser in size than your training data set. So it's detecting very less, points errored out in your validation data set. But again, these are some of the things that you need to observe when you are logging your model information. But again, very good observation.
Also, like the augmentation, we do it on the training part and not the validation. So, like validation loss would be lower in a lot of the cases. In that.
Yeah, ideally you would want that. Like you need your validation accuracy to be higher and your validation loss to be lower than your training one. But in this case, the training accuracy is almost like reaching 90% here. So that's a clear cut sign of your model starting to overfit. Yeah.
In one of the models that I ran, the training and validation stayed pretty similar, but when I ran it on the test data, that's when I saw like that it must be overfitting because that accuracy is a lot lower. Is there any other like indicators that would happen once you get to the test data, or is it just since we can't see like the testing data now?
Like you don't want your training accuracy to go very high. Like if your training accuracy is, ideally reaching 100%, that's like the ideal scenario that your model has overfit.
I see.
It has fitted the, training data set perfectly. So ideally you would want your training accuracy to be decent enough, but then your validation accuracy should keep increasing, even though it's a very slightly incremental change. Okay, so this is
I'm
one of the,
sorry. So
yeah.
just to confirm what we just said now, back to the last slide. So the inference of saying that this overfitting is not necessarily based on the fact that the validation accuracy is higher, because we just established that the validation data set is not as much, and there we're doing some augmentation, so maybe we're not checking the error as much as we are in the training. That's why it's maybe less in the loss. But it's the fact that it's not rising again. It's that's plateaued. Is that why we are making the inference that this is probably overfitting now?
Mm-hmm. Yeah, that's one of the right interpretations.
Okay. All right. Thanks.
Okay. So this is one of the, sorry.
So about the previous slide, how we can prevent that learning rate going that much low or like change the trend after a while? Like getting low, then getting increase.
That's also one of the issues here, like your learning rate has gone way, way lower. So one of the things is you need to check out what kind of scheduler you are using. And depending on the scheduler that you are using, what is the frequency or at which it is updating or reducing the learning rate. If your learning rate goes way lower, it's probably best to stop your training and then try again with a different learning rate.
But it's not like increase. There's no scheduler that increases the learning rate.
You can do cosine.
There is one
the
cosine annealing. You can use that for that.
How do you decide where to like decrease the step? Like how do you go about it?
Yeah, so that's again one of the experimentation challenge. Like you would have to, experiment at different levels. Like okay, this step is working, this step is not working, and that's why we recommend that you run your ablations as a group because there are many hyperparameter combinations to try out, and it's just an experiment from there on. Okay, moving quickly along, we have still like a few slides to cover. This is one of the sample, classic overfitting graphs. You can see, the validation loss, which is the, like the dotted line, has started to increase. So if you see something like this is like a very ideal classic scenario of your model overfitting, because your model has gotten too much used to the training data set, and now it's giving, it has learned noise, and it is giving like incorrect predictions on your validation data set, and that's why your validation loss is increasing now. So this is how you would go about addressing overfitting. One of the best ways is to just add more data. For this homework, you cannot do that. You have the data that you have.
We can like augment the training data, right?
Yes, you can do that. You can do that, yeah. One thing is you can add normalization, which I hope you are already doing. You can do data augmentation or transformation like time masking and frequency masking. You can try around with some regularization techniques like dropout. Again, once you have trained your model, it is up to you to analyze, like how your model is performing. In homework 2, part 2, this will become more clear because that will overfit wildly, and we'll talk about overfitting and addressing those challenges more in detail in homework 2. Okay, one last one, I promise. Would you continue this or stop this? Okay,
Stop it.
how many say continue? 1, 2, 3, 4, 5. Okay. On Zoom?
I think we should stop it because it's overfitting again.
It's over?
Like training accuracy is more than validation accuracy.
It is overfitting.
Yeah, model has started to overfit, but would you stop it? This is sort of a trick question here. So if I were in your place, I would not stop this model, because if you see the validation accuracy, it's still going up. Albeit slightly, it's still going up. Although there are signs here that the model has started to overfit, but you would run it for a few more epochs and see, if your validation accuracy crosses the high cutoff. And that's what you need at the end of the day. Yeah.
How many epochs is the ideal number? Because if you keep running it for a long time, like 50 epochs, that's going to take a lot of time. But if your model is oscillating, then there's no point of running.
Yeah, so you would have to keep an eye on graphs like this. If you see, your accuracy has plateaued and it's not increasing over epochs, stop it and just try a different run. Epochs is again one of the hyperparameters. You would have to figure out what ideal number works for you and your team and for your model as well. But in the industry, models are being trained for thousands and thousands of epochs. So 50 still seems like a very low number.
But I mean, I'm curious on your opinion about like plateaus, because I feel like sometimes like entire epochs, you maybe get like less than 0.1% increase in accuracy. And it seems like if that's the case on something like here, you're not getting a lot of value for like.
Yeah, I mean, there are signs of, accuracy plateauing here. So I'm saying that I would not stop training here. I would try it for 5 or 10 more epochs to see, if it still gradually slides over that thing. That is one of the things that you'll, see in your homeworks as well. For homework 1, part 2, maybe you're stuck at 85.8. And you would, still want your model to snail over that high cutoff slowly. So try and run it for 5 more epochs, 10 more epochs. Hey, whoever posted this meme, I'm a big fan. I'm a big fan of Tom and Jerry. So again, a very classic overfitting example here. You'll see this in homework 2 a lot more. Talking about some runtime issues. So you'll have runtime issues. Oh, you can, how to go debugging that. You can read the documentation for PyTorch. You can, if there are some GPU related errors, it is possible that the traceback will not show you any errors. So a step that you can take is try to, put your model on CPU decrease the batch size, and then run it, because sometimes CPU gives you the exact message that GPU cannot. So that's again one thing to keep in mind. Learn to use PDB, and there are many resources that you can check, like Stack Overflow, like many people discuss what kind of errors are there, and obviously, the TAs are there to help you out as well. If we talk about memory issues, so let's say you are running out of memory, which I think many of you did, like you reached out to some of the TAs, like your CPU is running out of memory, your GPU is running out of memories. So in order to handle sort of those situations, you'll probably run into this error at least once throughout the semester, like CUDA out of memory. One of the options is that you can reduce your batch size. You can use mixed precision training, which uses like floating point 16 rather than FP32. You can, when you check if you have put your model in inference mode when you are evaluating that model, because that is important. And also there's this last line here, you can also call the torch.empty cache thing, because if there are any leftover stuff in your cache, it is a good habit or a good practice to like clean that out regularly. This is again like one of the errors that you'll see in one of the homeworks. So as I mentioned in one of the earlier labs, it is important that you put your model and data on GPU or on CPU. Both of them needs to be on the same device. So just make sure that they are not on different devices, because that will lead to inconsistencies. Time issues. So I see some of you are also reaching out regarding time issues, like your model is taking very long to train one epoch. So things to check is like if you're using GPU, if you're using CPU, then the training will go slower. Check your batch size if it's higher or lower. You can also use mixed precision training. So mixed precision training is to optimize your training speed. And you can also use time module to see which part of your model is taking a lot of time. Although Colab already does that for you. When you run a cell, it shows you like this much time it took to run this thing. Okay, last part here to discuss is the testing in Kaggle submission. So I see many of you have already faced this, like when you are trying to go and submit your Kaggle submission files, you are getting like 0% or 0.05% accuracy. So we already made a post for this on Piazza. Some things to check is like if your order is correct, if you have sorted out the test files, do ensure that you have sorted out the test files. Ensure that you have mapped your phoneme IDs to the exact phoneme labels, because that is what the solution expects. So just keep an eye on that. One other thing is like so if this example is given, what are the number of entries that your submission file should have? This is not related to homework 1 part 2. This is just a sample data set. If you're using this, how many rows of data should your sample submission have?
1039.
1039, because the test data set has 1039 samples. So just ensure that the number of samples in your test data set are matching the number of entries in your submission file. And just a general strategy for debugging some of your models. I think I've mentioned this before. Start very simple. Start simple. Try and reach the low cutoff, which I think you have already did. Once you do that, evaluate your model incrementally and tune the hyperparameters. Divide the ablations among your study group, and then meet the requirements of the homework. That's pretty much it. Thank you so much. Any questions? Also keep the meme thread going. I love seeing this. Any questions?
So what are the documents that we have to submit for homework 1 part 2?
Part 2? Like you're talking about the Kaggle submission or the final submission?
I mean, yeah.
After that?
Autolab.
Autolab. Yeah, Autolab, you'll have to submit your notebook file, and you'll have to like give instructions how to run that file and what you have done and what sort of hyperparameters, different configurations you tested. So you'll maybe keep like a README cell at the top of your notebook mentioning all those details, because we'll go and run that notebook once you submit it on Autolab. Yeah.
Is it required to submit a notebook file or are the Python files also?
Python file should also be okay, right? Yeah, Python file should also be okay. And just to mention that another point, so there is a seminar in NSH room 4305. Definitely check that out. I'm also going.
The meeting's recorded right now?
Yeah, it's at 9. It's from 9 to 10.
Is it on recording?
Yeah.
I have some questions.
Yeah.
The context is that padding in the front and the back of the utterance. In the write-up it says there are two ways. One is to protect everything.
Yeah.
And one is to how much consists of an utterance? Is it a file? Is it a single utterance? Or is it,
Yeah.
is it
Yeah. One file is one utterance.
one file is one. So if we pad each file with starting zeros and ending zeros.
Again, like, yeah, because that would be tricky to implement, because you would have to keep track where your padding is starting, where your padding is ending for each of those files. And there are around 2,700 files. That's one of the options you can try, but